All right, thank you everybody for joining us for the Friday, February 18th meeting of the Champaign Blockchain Meetup Group. We are joined by Neal Davis from the Urbit Foundation. Neal's also a professor of computer science here at the University of Illinois. But your degree is actually in nuclear engineering, isn't that right?
Right.
So what did
I've been kicking around a little.
What's that?
I've been kicking around a little.
So you just did enough work in the modeling side that you just wanted to become a pure code person?
So basically that's what happened. I was studying electronic structure of uranium surface chemistry. And that's a lot of cluster and supercomputing work. And that led into me teaching engineers how to use computing resources effectively with a unit inside of College of Engineering. Some of it was cluster oriented, some of it was very mechanical, like how do you log on, how do you set up your jobs and your instrumentations. I did other things that were computational fluid mechanics, structural mechanics, and pure mathematics, linear algebra solvers. And that was a lot of fun because I got to do the opposite of a PhD at that point, right? It wasn't broad, it wasn't narrow and deep, it was broad and shallow, getting exposed to zillions of different components and ideas. And then that ultimately led into my position with computer science, where I've been teaching, mainly I've been teaching engineers how to use computing effectively. So I teach intro programming and I teach a lot of software computing tools, and I'm mostly voiced towards non-computer science engineers. So civil, mechanical, nuclear, physicists, chemists, all of these.
That's fantastic. And what led you to become involved with the Urbit Foundation, and what do you do there?
Mm-hmm. So Urbit is it's a project that today is getting slated under Web3. It's older than Web3, and it's actually about the public launch of the project is about as old as the blockchain itself, right? With Bitcoin, it goes back to 2010, 2011 era. But I got involved with it through learning more about the technical platform of the system and how that worked, and I found that very fascinating. That was probably around 2019, and there's a lot of new and innovative ideas that are rolled up into this project. Some of them are essential to what the project is, and some of them are not, but as an opportunity to try a new memory model or other computer science aspects of what's going on. And I got very interested and involved in that, and I ultimately ended up teaching a grad seminar on it in fall 2020 that was looking at it from a highly technical perspective and going into the kernel of the system and analyzing how everything was behaving in that regard. And since then, I've done a lot of open source work with them and contributed. And then in January, I started working with them on developer experience. And so I've been doing that, and I'm kind of moonlighting right now, and I'm joining them full time in May after the end of the semester, and my current teaching commitments are completed.
Very cool, very cool. Will you be relocating then to be with Urbit, or are you going to be staying here, keeping an affiliation with the university?
Yeah, I'll be staying here. It's a fully remote project basically at this point. When everything hit in 2020, they had largely been based in San Francisco, and at that point they just decided to scatter to the four winds and run everything remote, and that's what everyone in the project has done since then. Administratively, it's kind of interesting because it's a case where you have a for-profit company that was doing the primary development from 2010, 2011 until today, and they continue to exist and do development. But at the beginning of this year, they spun off an open source nonprofit foundation, which is the Urbit Foundation, which is what I'm involved in. And the mandate of that organization is kind of like the Linux Foundation, where they're going to ultimately take over, kernel and platform development and education and a lot of coordination among the different companies that are now building on top of this platform. So administratively, it was an interesting time to watch. How do you break a group into two parts that have different targets, and do this in a smooth way that keeps everyone involved and following what's going on.
Very cool. All right, so tell us a bit about the project. And so I guess start off like, what is Urbit? I know like the Urbit is, what would you call that? If I have an Urbit, is that my kernel, my node? How do I think of that?
Right. It's a little bit messy, and there's a lot of layers of explanation that people have tried over the years. So there's not like one clean elevator pitch. I think it's become a lot easier to explain it now because there are things like Web3 and there are things like Dowse that people understand, and so it's easy to talk about it. So there's a long time where they would talk about, well, it's a personal server, and people say, well, what does that mean? So I think there was a sense in which it was kind of a project looking, it was a tool looking for the right place to work for a few years, but I think it's found that now. So Urbit is a computing platform, I think would be the best way to describe it, that allows you to have complete data autonomy in the sense that anything that's working inside of the Urbit ecosystem is working with you holding all of your own local data and your local agents and interacting with others through network messages. It's built on a functional as in language virtual machine. So it has an extremely good notion of state and reproducibility, and it's end-to-end encrypted. It is, there are secure, stable identities. There's a finite number of them. It's about 4 billion, and there's ways to grow it if we ever get big enough that actually starts to be a limiting factor. But I'm not thinking about the 4 billion user mark at this point. And so Urbit as a computing platform is, I think, the short way of what I would answer. In the same sense that something like Facebook is a computing platform, right? People think of Facebook as a website, right? It's a portal that allows you to do certain things, to view your feed, to watch what's going on. But Facebook is also a computing platform because there's a lot of things that are built on top of it. They expect your data to be in certain places, to behave in certain ways. You can do transactions of identity and transactions of money and other things on the Facebook platform. It has its own currency that they've been working on spinning up. So Facebook is a computing platform. In that sense, Urbit is a computing platform that you're running a local instance of the virtual machine. It has your own identity on it, and you're interacting with other users of the system. So it rolls together a lot of pieces that we're used to thinking of as separate tools. Right now, if you start a new project, like let's say like this blockchain meetup, right? So, there's meetup.com for organizing meetings and communications, and there's Zoom for actually running things. And if you were doing more than that, then you might want to have as much as a bank account. You'd probably have some sort of financial handler, maybe via Eventbrite or Meetup or whatever you're using. Maybe you'd have a Slack or a Discord that was associated with it. And everything would exist in this extremely fragmented state if you wanted to scale that up. And even communicating this to people who are joining the group coherently is kind of a problem. And this is a situation that DAOs, right, decentralized autonomous organizations, which are the blockchain organizations that we're seeing more recently, that they're running into all the time. One of the advantages of Urbit is that because it's a computing platform, it lets you reunify these things the same way it would as if you were going to say, commit to the Microsoft stack, right? And you're going to use Microsoft Teams for everything, and you're going to use, Outlook, and you're going to use Excel and Word and all of these tools, right? Where you have this whole suite of applications, and you have this identity that's tied to those. But the problem, of course, is that you're subject to whatever somewhat arbitrary decisions Microsoft makes about the usage. There's the end user license agreements, but there's also just, they may change things that break your compatibility, break your workflow. You don't really have any control over that. There's data privacy issues that get involved with that. I mean, I'm old enough that I still have kind of the late 90s cypherpunk, $$ viewpoint towards Microsoft. I admit that they've cleaned up some in more recent years, but there's a lot of bad blood in the old Linux community if you poke around for that. So Urbit as a computing platform is trying to replicate that kind of a stack built in such a way that you will always own all of your data and you will have control over where and how it is used. Everything, like I said, is end-to-end encrypted. It is tied to certain key cryptographic identities. Yeah, I think that's the rambling, shortish explanation of what's going on with it.
Okay.
Do you want me to just launch in, or
Yeah,
to what I
please
was
do.
going to talk about today, or do you got another
Excellent.
question too?
Go for it.
Okay.
I should make sure that you have ability to share your screen. I suppose that usually helps.
So I was going to show you all a couple of things. One of them was I have a short presentation here about what Urbit does for blockchain users, and then I can go back and talk a little bit more about like what Urbit is, which you know, people often walk away from these and say, okay, well, that's great. I know what Urbit does, but I don't know what Urbit is. So we can circle back around to that, and I'm happy to answer questions about it. So one of the issues that I want to start off with is like, why do people actually use blockchains, right? Like what is the utility that they get out of blockchains? So there's a few things. You know, the oldest one, of course, is money. Bitcoin, Litecoin. There's a number of technologies that are basically built right on that initial technology stack, the Satoshi Nakamoto, where you're using whatever's going on in the blockchain as a coherent way of organizing your finances, right? Where you hold this value, it's in this public ledger, or maybe you're doing, you know, Zcash or Monero or something, and it's actually private, it's completely anonymized, but you're interested in using it to track money. Another reason that people like different aspects of blockchains is for identity and attestation. What I mean by this is you may have run into situations where to participate in a certain project, you have had to attest on the blockchain, right? Like you're demonstrating somehow that you own a wallet, or that you own a particular access point in that message space, which, you know, analogously is a wallet. The way that like the Ledger project handles non-repudiation. Sometimes some of these are used for messaging. So there's a lot of ways to do this. I mean, so for instance, there's the whole issue with Craig Wright and the identity of Satoshi Nakamoto, where people, you know, there's someone who has claimed to be Satoshi Nakamoto and have invented Bitcoin, and people have said, well, show us that you control any of the wallets that we know belong to Satoshi Nakamoto. And he's been unable to do that. So therefore people are skeptical that because he's not been able to attest his identity on the blockchain. Computation has become a bigger one, particularly with the rise of smart chains and smart contracts, starting with the Ethereum virtual machine and building out in many ways. Many projects have adopted smart contracts. And so this is what we're doing with computation. It is a general purpose machine in the Turing complete sense, where you're actually able to carry out any arbitrary computation, but you only want to carry out certain kinds of calculations on the blockchain, because the blockchain is globally distributed, and as you can imagine, right, it's relatively inefficient for that reason. And so you end up writing contracts in Solidity or some other language. Maybe these work well, maybe they don't. But this is why you're paying gas, is to defray the cost of whatever your computation was. There's a lot of financial services that people are interested in. I'm separating these from money because these are things like escrow without a third party, which is essentially what a smart contract is doing. There are insurance models that are getting built on top of blockchains and the way that they behave and treat things. Messaging, which relates back to identity and attestation that I mentioned a moment ago. Unique ownership is one that has been turning up a lot with NFTs, right? NFTs are only, they're getting all the oxygen right now. They're probably 1% of total, blockchain capitalization. But there's definitely a group of people who are convinced by the idea of uniquely owning something that is attested on the blockchain. Now, this can be the NFTs where people are trading JPEGs essentially, And people joke about screenshotting and everything, but there's also been land transactions, right? Real estate transactions that have taken place on the blockchain, and places like Wyoming have been interested in pursuing this. So it's also will serve in the future as a proxy for certain kinds of physically attestable deeds. And then, of course, one of the more cynical things is that this is an investor, blockchain is useful as an investor exit, right? Where you run your initial coin offering, and this gives everyone a chance to cash out who had invested a lot of money in the project, and then they're done and they walk away, right? And so that's more cynical to phrase it that way, but it is, in any case, whether or not it's a scam, it is an investor exit in the same sense that an initial public stock offering would be, where it gives them, long-term investors in a project, a chance to cash out in a way that they can tie back into their legacy financial system. And the Urbit project has been built around some of these concepts. Yeah, let me address this, because these things tie into what I'm going to say next. So I told you it's end-to-end encrypted. So it's like using Signal, a little bit tighter encryption than something like Telegram. It's peer-to-peer, so it's a fully decentralized platform. There's a hierarchy of nodes, which is like a particular point you own in the address space. So it still has a decentralized backbone, like the internet has a backbone, and you have to go through an ISP or someone who has ISP level services to access other points on the internet. You're not going to completely get away from that on any future system, because most people aren't going to host and maintain infrastructure. So there is a higher level set of nodes that are maintaining infrastructure. But that's only for route discovery and routing. And then once you have contact with another point in the system, all of your transactions can be purely peer-to-peer. And it's tied to a cryptographic identity that you own. So in a sense, it is kind of like an NFT, right? You can attest that you uniquely own this, but it's like a wallet. It's like saying that I own this particular address in the network, and no one can take this away from me. And it's what corresponds to my collection of data and values and identity that I'm carrying around. Urbit, so that's what Urbit offers as a computing platform. And what it is a virtual machine that maintains the state of your entire system in an event log. And so this has been branded as the 100-year computer, right? Like they're aiming for permanent future compatibility in the system, so that if you take an Urbit today, you run it and you stick it on a flash drive and you stick it in a drawer, then 100 years from now, if you can find a USB drive 100 years from now, you can plug it back in, and it will have an upgrade path so that it continues to work and be compatible with the rest of the system. So it's very much architected around how do you carefully do anything you do in your system so that you're not breaking the state at any particular point. And this has been it's been a good discipline, and it's a lot of fun to talk to the software engineers who have been building this, because they've been thinking very carefully about, what are the kinds of things you can do given the constraints of a functional programming language, right? Functional programming languages like Haskell or OCaml that are very mathematically oriented. They're trying to make strong guarantees about the kinds of interactions that you're doing. And in a sense, you would contrast this with a language like C, which is what most systems are written in. Windows is written in C++, or was for a long time. It's probably a lot of C# now, which are a little more fast and loose, and you can do direct memory accesses and other things that kind of break state that step you out of your identity at some particular point. Okay, I'm just keeping an eye on the chat in case any questions that come up. All right, so what we're going to say, like why Urbit matters to blockchain people. So Urbit does have a blockchain component in that the cryptographic ID, the identity part, is currently hosted on top of the Ethereum blockchain. And it does have layer 2 rollups and other fancy aspects of the way that the Ethereum virtual machine works. But that's its only direct connection to blockchains, is that the identity points, the ownership of a node on the address, is maintained on a public ledger via Ethereum. What Urbit does allow you is it allows you to maintain off-chain computations in state. And this is valuable because there's a lot of things that it's hard to do on a blockchain because a blockchain smart contract doesn't know a lot about state, right? It's hard for it to keep track of in a consistent way, like things that happen off of the network, right? So if you have gambling that's predicated on, let's say you have blockchain gambling and it is predicated on the outcome of some particular contest. It's a boxing fight. Someone has to basically enforce this state on the blockchain for those smart contracts to resolve. Right? It's not just about is money moved between one wallet and another. There's different kinds of external real world state that have to intervene for the smart contracts to complete the way that they were intended to by the humans that were involved with it. But since on-chain computations are expensive, being able to do off-chain computations that are still verifiable, right? Because it's a functional programming language. These are basically auditable, verifiable calculations. You can then feed these back into the blockchain to make better decisions. Similarly, you're able to keep track of what your state and your metadata around any particular project are, like what these things actually look like. It's basically because you have personal keys, so you're able to associate things with a wallet that otherwise you would have to, you'd be keeping on a text file on your computer or some terrible leaky workflow like that. There's incentives for pro-social behavior on the network. So by limiting the ownership of address space on the network to people who are willing to, get a point, access a point, you can buy a point, you can get a point given to you from various sponsors on the network. There's a lot of ways to do it, but it gives you Sybil resistance. It gives you resistance to the entire current layer of spam and bots that exists on the internet, and it protects you against a lot of categories of virus. Once you have end-to-end encryption and peer-to-peer access, getting a virus in the classic sense to transmit across the network is a lot harder, right? It's kind of like if you go back to the late 90s, early aughts, Macs were perceived as much more secure against viruses than Windows machines were because of the way that they handled the way that Next Step built what became the Mac OS kernel. And, this has become less important over time because people have better scanners and other systems. But anyway, it's a categorical supersession of the current layer of spam and bots, and it gives you Sybil resistance and some protection against denial of service attacks and these kinds of things. Now, I think the big one, and the one that has become much more important in the past couple of years and will continue to grow in importance, is that it's getting the platform is getting to the point where it's going to provide those who want to run blockchain-oriented operations and organizations, in particular DAOs, will have operational tooling out of the box. So they already get signal grade end-to-end encrypted communication. There is a WebRTC-based voice and video communication, so basically Zoom on platform. You can do this on the web, on the Web 2.0 if you want, where it means you're using Reddit, but make sure it's a private group. Use Google Docs, but make sure everyone has a Google account associated with it. You can use iMessage or Telegram or something, but everyone has to have an iPhone to use iMessage. And everyone has their own login and security holes, and everyone's mining your data and your behavior and trying to put all these things together in a messy way. And so there's a lot of incentives to get away from the legacy mega corporation tools that are out there. And Urbit has been seeking, with I think a lot of success, to resolve those issues in a way that will be instrumental to people building organizations on top of Web3 and blockchain-based technologies in the future. Essentially, that's my spiel, and that's why I got involved with the project, why I'm excited about the project. I kind of got sucked in by the technical aspects, but I'm really excited about the social implications of the technology and being able to build out on top of this sort of secure thing. So I was going to show you briefly too what it looks like to actually, well, problem is like, what do you, like showing someone Urbit is like showing someone Bash or Terminal on a Mac. There's sort of like not a lot to show because it's code and it's what's built inside. So I'll actually refrain from that right now. And I'll bring that up if that comes up in questions. But back to you, Adam.
All right. Well, thank you. That was a lot of information. I was curious about the DAO tooling that you were talking about enabling this decentralized cooperation. Could you go into a little bit more about that and how Urbit enables that?
Okay, cool. I'm really excited about DAOs, right? So for context, I think we actually talked about this a little bit last month, but so the original DAO, the original decentralized autonomous organization, was a group of Ethereum users who were basically pooling their assets to carry out certain operations. And it was an organization that was built on top of Ethereum and the Ethereum virtual machine, and you're able to basically buy into this as kind of a second level token on top of Ethereum, and this gave you participation in this DAO. The first one got hacked. They had some bad code in their smart contracts because Solidity is not a particularly good smart contract language. What I mean by that is that it's easy to write a contract in Solidity that you think you understand the implications of, but you don't actually understand the implications of, because a lot of the messages and the way that it deals with things are leaky. And so, right, there's a whole industry of people who audit smart contracts in Solidity because of this. Anyway, so if you're building a decentralized autonomous organization, typically it has a mandate, it has a plan. There was a Spice DAO recently that bought the Alejandro Jodorowsky's original Dune script, and they're trying to publish it. There's a Constitution DAO that was trying to buy like an original copy of the U.S. Constitution. There's a lot of like niche ones out there. Some of those are more interesting than others, but what I'm particularly interested in is the idea of being able to create new forms of organizing with people around you in a way that ties together your intent for how you want to operate with the world. So if you want to basically jointly buy stock in a corporation, assuming it has a way of actually making this legible on the blockchain, whatever blockchain platform you're using, Ethereum or Cardano or Solana or whatever you're using, then you're able to basically team up as a group and make this happen, right? Like make these kinds of operations available. You can use this as a coordination mechanism for purely financial reasons. You can use this because you're trying to pool money and buy something bigger that would not be accessible to any of you. But because it's done on the blockchain, it also means that the finances, et cetera, are more transparent to you than they would be as if you were, sending money into a bank account, and then you're not really sure what happens with it at that point, right? There's a whole category of scams that exist around getting people to donate money to some cause and then just skimming that money off, right? Blockchain doesn't completely solve that because you got to make sure your smart contracts are solid, but it offers a different way of thinking about it. And at least with auditing of smart contracts, in principle, you can get to a higher level of confidence around what's going on. And so one of the flaws of DAOs, in my opinion, is that they don't allow very well for different hierarchical or specialized roles, right? Like when you're part of a DAO, you're sort of bought in at this flat level, and it's purely determined by investment, right? If you buy more tokens than someone else in this DAO, you have contributed more money, and maybe the value of your investment changes because people are paying more or less to buy those tokens, right? There's a related liquidity problem, but basically it's whoever has put in the most money has the biggest voice, and then you're trying to build coalitions to make sure you get the 51% that controls the government of whatever's going on. In human organizations and human associations, we've solved this to some extent because most associations, like a bar association or a faculty or Freemasons or whatever you have, right? They designate someone as, here's a treasurer, here's chairperson, here's a spokesperson. You know, they have different things that they've allocated for you to do. And so there's some of these are executive in nature, where they are empowered, given plenary power to carry out certain actions, maybe all actions for the group, unless that power is revoked. You know, that's what you want from someone leading an organization, right? There is a vote of no confidence that you can undertake that would take that back. But right now, as DAOs tend to be structured, it's whatever shifting coalition of 51% manages to govern what's going on. So, you know, it's got some mixed things going on there. I think there's a lot of I think there's a lot of promising work to be done in building a little bit more hierarchy and specialization into DAOs than what they currently have. And I think the Urbit address space structure actually has a good precedent for how to think about doing that. So that helps. Yeah, I don't know if I have anything offhand else to say in response to that question, but.
No, that's great. And Robert asked in the chat, if you could show us what Urbit looks like. He said, even though I'm not a coder, seeing it in real life would be interesting.
Okay, so I'm going to show you 3 things then. I'm going to show you what it looks like to run it. So it's a computing platform, and it's like Facebook. There's a way to access Facebook through a front end, and there's a way to access Facebook through the back end, right? If you're an engineer sitting at Facebook headquarters, what you see when you look at or think about Facebook is very different from what you as an end user think of and see when you look at Facebook. So I'm going to show you what the interactive prompt looks like and just a little bit of how it works, but it's basically a programming platform. I'm going to show you what the front end looks like, which is currently largely browser based. There are some other clients for it, but most of the time you're just running your tools through the browser. And then I'll show you what the code looks like, because I think the code is fascinating and I love to get into the code. So let me show you those 3 things. Let's go to, where's my share screen? There we go. All right, I'll just share my whole window here. Oh, it's just changing my font size. Okay. All right, so I'm going to cd into my Urbit directory here. Should have something that'll work. All right, so you would run it on your own system. And what happens in any particular case is if you're running, you know, actually that one's probably going to be obnoxious because I have a background process running there. Let me do, I'll let this one run. Nope, that one's broken. I also do a lot of development, so I'm like breaking things all the time. Let me find one that is actually running. Oh, sorry. I didn't come planning to show you the back end, but I'm going to show you the back end. All right, I think this one will work.
That's cool.
Okay. So I'm running Urbit, and so what I have here is like as if I were running, you know, Python or MATLAB or something else, or even just opening up Terminal on a Mac or the command line on Windows. It's waiting for input from me, and so I'm able to do certain kinds of calculations. It's Lisp-like. The language is Lisp-like, and so you know, here in this case, I'm adding 3 and 4, and I'm writing in a Lisp-like operation. And so this is essentially a programming platform, and then it's also giving me a lot of log messages about what it knows about the network and everything. So this is kind of like, you know, looking into the matrix, where we're seeing the back end of how all of these things behave and what they feel like. But it's a Lisp-like programming language. If we are going to look at the front end, that's going to look something like, this is one of the apps on it. Let me do, you can install different programs on it the same way that if you were running in Facebook, right, you can install different games and they would do different things for you. And so these are some of the programs that I've installed on my own program. So there's a Bitcoin wallet, for instance, that I can use to do Bitcoin transactions. And some of these are for groups is the one that you mainly spend a lot of time in, or Escape, which are the social media front end. And so right now, a lot of the activity is done on the social media front end. And so it takes a second to load, and now it's pulled up, and I'm able to sort of click in and look at basically this is my social media feed right here. And so there's previous discussion between people of what's going on and talking to each other and interacting. And then I don't have the WebRTC component installed on here right now, but that's another kind of thing you can do on here. There's some games like chess and some other things that are built on it. The game part hasn't really been built out yet, because up till now I would say that the platform is in a developer beta right now. Like, it's definitely the proof of concept has been done. Like, here's a Wordle clone that you can do. Right, so you can play with how these works and see how these behave. So those are all there. That's what the front end tends to look like. So it's like Discord or something in the current front end, but there's a lot of applications you can use. And then if I'm showing you what the code looks like, let me. All right, and so the code tends to be very structural, and a lot of times what you're describing as you look at different parts of the code, instead of keywords, it uses these ASCII digraphs called runes to relate everything. So it's kind of like programming an APL or a language like that. I think a lot of people don't perceive it as particularly beginner friendly, but once you know it, it's an extremely powerful language, because it lets you think a lot about the way that the different structures in your code are relating to each other. It's sort of like it's the C analog of for the Urbit platform, but it's an extremely powerful language, actually, that's letting you do these sorts of things. So the names of things tend to be a little bit obscure and esoteric, but it's okay. Like the soul of the system is its persistent state, which makes sense if you think about it for 2 seconds. But that's what that behaves and looks like.
Nice. I couldn't help but notice you scroll past a folder called DC Spark. Have you had any work with the Urbit Visor that they work on?
Right. I actually was consulting with them last fall.
Cool.
And so I consulted a little bit about the DC Spark and how that was behaving. So I built a couple of apps for them that are behind the Visor, but it's not end user stuff. It's not stuff that you would ever know you're using. Okay. Ideally, right? Most platforms, you don't log on to Facebook and want to see code. That would be a mistake, right?
Sure. I'll open this up for other questions from the crowd. Oh, I see Robert had the same exact response as me. I've seen the DC Spark folder. So
I don't know the answer about is it Milkomeda or Milkomeda? I know I've heard them say it, but I don't know offhand what the
it's Milkomeda, right?
Milkomeda.
Yeah.
It probably is.
That's all I always say to my head, at least.
Yeah. Well, I think what's going to happen, I don't think it'll be Milkomeda for buying. Okay, I guess I should address like what the address space looks like, because Robert makes the point about planets here. And so hierarchically, there are basically 5 different kinds of identity points in the system, which everyone's like, oh, why do we have 5, right? There's the top level routers and basically the network infrastructure governance points that are called Galaxies. And there's 256 of them. And then there's a collection of stars. Stars are basically in the future, they're going to assume the bulk of peer-to-peer routing. And so that's going to be their role in the infrastructure. And they're probably going to be service providers. So for instance, you can run a Bitcoin full node, and then everyone who's subscribed to you can use that Bitcoin full node for any transactions that they want to do. Then there's planets, which are intended as individual identities. And so most people on the network are using planets for everything that they do. So that's a regular point on the network, and there's about 4 billion of those. There's two other kinds of points that don't get used as often. One of them is moons, which are associated with a planet. So galaxies, stars, and planets are independent identities. If you own that identity, you own it, full stop. And anything you do with it is verifiably yours. Moons are subsidiary, and ultimately they're intended to run like Internet of Things style devices, right? You don't need to own a new network address point to run your Nest, but you do at least have to have, a local, 127.0.0.1 style local host address point on your local area network, so that you can interact with it. And so that's what the function of moons is going to be. So they don't get used a whole lot right now, but they're built in there so that in the future they'll be able to use them. And then there's transient points called comets that ultimately I think are intended to function as bots. Basically, whenever you need to spin up basically a thread, just something that would go complete a process, and then you don't care what happens to it after that point, right? There are rules for that. Right now a lot of that happens with spammers, but there are legitimate rules for that kind of disposable identity as well. So those also exist. So for most people, I guess the rate that things have been going lately, planets were expensive to get for a long time because of Ethereum gas fees. Like we're talking like $200 to $600 because of what happened to gas fees. There was a layer 2 rollup that went live in late January that's basically cut that rate to like by 99%, literally. So planets are functionally free right now. It's like $2 and you have an identity on the network, and it's easy to find lots of people that are giving them away for free. So those are fine. Yeah, I think that's what's worth saying about the network address space structure.
Gavin had a question about how this off-chain computing, how does off-chain computing interact with existing blockchain, the Ethereum network in this case?
Okay, so what we have right now on up and working on Urbit, we have Bitcoin integration, but that's all money transactions. So, it looks normal, right? You can just transact. And we have Ethereum integration, which is largely architected around managing the address space, because the address space ownership is managed by the Ethereum blockchain. And so there's some tooling around that where you can do off-chain transactions, transferring a point from one person to another, from one wallet to another, and then that gets sent as a transaction up the chain, goes back to the chain. Basically, it's functioning as a traditional smart contract in that case, where you're pushing the new information onto the blockchain and it's being verified by everyone in the conventional way. In the future, they're building a new layer 1 blockchain called Uqbar on top of Urbit, right? The names are all terrible because they're all from Jorge Luis Borges stories. But they're building a new layer 1 blockchain on top of Urbit, and there's going to be a lot of things that are done on there. But there's also we're in the process of building out clients for interacting with other chains. So we're going to try and make it as generic as possible in the future. We haven't been building for everything because the philosophy has been it's better to build it slow and right, which you may or may not agree with, but there's a lot to be said for like move fast and break things. But the philosophy up to this point has been very, very mathematical of, we're gonna prove that we can do this correctly before we do anything at all with it. And so they've been relatively slow about giving you interactions on other blockchains. Now, if we're saying hypothetically, right? So let's say we have an integration with Tezos or Cardano or something like that. And let's say you have a system where you want microtransactions, right? You're running a game and there are microtransactions in this game. Maybe it's gambling, maybe it's just pay to play, right? There's a lot of reasons to have microtransactions. Well, you can do a lot of things where you're doing the calculations that yield the final state, almost like Lightning Network style, or where you're basically doing a roll-up of transactions and then submitting that roll-up back to the chain, or where the calculation that yields what the final transaction output should be would be extremely expensive on the chain, but you have an auditable, verifiable way of demonstrating to everyone that the calculation was done correctly off chain. So you can do the calculation off chain and then push it back onto the main chain, just pushing the result rather than the calculation itself. And there's ways you can do that, like with the hash, right? You can guarantee that the calculation is proven to have been done via this hash, because there's no other way for you to get the correct hash of that value. So that's some thoughts around it. So my plan for when I end up going full time to Urbit Foundation in May is I'm going to spend the summer working on DAO tooling and trying to build this out into a more coherent product vision. So it's definitely something that's on our radar, and there's a lot of things that are possible, but still hard. And I'd like to make them easy so that you can get people doing the things they want to do with DAOs as a result of that.
That's very cool. Any other questions from the audience? Oh, there we go from Robert. Would it be possible to create more galaxies in the future for greater decentralization?
So by the structure of the address space, no. It would be straightforward to disperse them more than they're currently controlled. So I think if you take the founding company Tlon, you take Urbit Foundation, and you take the venture capitalists that are invested in it together, that's something like 70% of the galaxies are in like relatively few hands. So most of the governance is done there. And I think for this early in the system, like that's fine. I mean, we're not building this out. Mostly the galaxies are built around network governance issues, which doesn't even mean like network access, the way that you're sort of subject, with companies now, you have at will contracts, so they can basically terminate you at will if you do something they don't like. And so, if you say something on Twitter they don't like on Twitter, they can kick you off, left or right. I mean, this has been happening all over the place. Facebook does the same sort of thing. And there have been cases where the entire financial system backend has refused to carry out transactions for certain parties or groups for whatever reason. And so what that highlights is that there's already a fundamental unreliability in the system. What the galaxies are going to be doing is networks governance issues, such as, what should the structure of internet network packages look like when they're operating on this network? This tier of technical infrastructure governance. So I would argue that there's not really a need, like what you get from decentralization, you already get from having 65,000 stars and 4 billion planets, and that the galaxies are not going to be the choke point on the behavior of the system in terms of the benefits of decentralization. So you do have a hierarchical network address infrastructure, but it's largely built around making sure that the network continues to work.
So how do you guarantee censorship resistance?
Well, if you're end-to-end encrypted, then as long as someone isn't explicitly blocking your packages from routing through their point, which would only bar discovery, not peer connection, because it's peer-to-peer once you have network, mutual network discovery, you can't. Right, okay. Like it is like using Signal. Like how do you block Signal? Well, it turns out you really can't block Signal.
But
so imagine it's Signal, but it's Signal for every packet on your computer.
And this actually leads into Gavin's next question. If you own a star, can you create a planet, and how does hierarchy ownership work? Does that mean, though, that if a person who controls the star, could they then, if they discover a planet is owned by someone they disagree with, could they censor that planet completely? Okay.
Yes. So there's two things going on here when we talk about censorship. So there is a set of smart contracts that are associated with this called censures, like CENSURE. And those are designed to, if you're a star or a galaxy, you can censure a point that is behaving badly in the network governance sense, where they are, if they're spamming, then you can censure them. And what that does is that lowers their reputation by a point for everyone who votes that way, basically. And, you can revoke a censure later on if the planet, changes hands or something. So there's kind of a purely technical level of, you can censure a point, which means that other people are less likely to trust it. The same way that, if I'm going to VodLocker to watch a video, I'm not going to click on anything that pops up on my screen, right? I know that that's a bad idea. So it's sort of that tier of behavior. So there is censure, but no one is bound to follow any particular censure. It's just that there is kind of a net aggregate idea of reputation on the network. It exists in practice. It's basically never been used. So, we'll see how it behaves in practice later on. Then there's censorship in the sense of, can you block people from interacting with other people on the network? And you can't. You can block them from interacting with you. So for instance, there is a chunk of address space, of subsidiary address space associated with every point. So if I own a Galaxy, I own a chunk of stars that are associated with it. And if I own a star, I own a chunk of planets. And then I can give or sell or whatever. Like, this is how everything's distributed out into the ecosystem. So if you own part of it, like the initial investors, mostly, they own Galaxies and things like that. Some people, there's a guy who won a Galaxy in a contest. There were people who own Galaxies because they were in the right place at the right time, which is fantastic, because Galaxies are currently changing hands for, $2-3 million. So, hey, that's a great thing to just get your hands on. You can block people from interacting with you, period. But if they're like a planet and you're their sponsoring star, which means that you're responsible for their peer-to-peer routing, and you block them, they can change their sponsor to a different star. It doesn't change their notional position in the address space, right? They still have a location in the address space that's hierarchically under your star, but it means that all of their transactions go through their sponsor. So there's always a reroute around. So to actually get censored, you would have to basically, tick off 65,000 people to personally bar you from interacting with the system. I mean, there aren't that many. There's a lot of address space that's not used right now, so that's hypothetical. But it's basically, there's always routes around censorship in the system as it's built.
It's a high bar. I think I might know a few people who can get that annoying. But anyway,
we'll put them to work. Well, I do want to stress test some of these things someday.
Yeah. All right.
We need a Ropstein network.
Cool. Well, this has been a fascinating and very thorough examination. Are there any more questions from the audience?
If you're interested, Urbit.org is the place to start poking around, and ask me questions. I come to these meetings pretty regularly now, and so you can find me, and I'm happy to talk about things. I'm also on Twitter and can answer things there. And if I typed it right, yes, I did. Okay. Sorry, the transcript is coming up right over my chat box, so I can't see what I'm typing. So.
Yeah, Robert says it's been absolutely brilliant, and very happy that you'll be working on DAO tooling, and I agree. This is a very exciting prospect. I think I really feel like we need a lot more tool sets for decentralized coordination like that.
I'm excited to build it. It's going to be, I mean, DAOs are going to be like the default way that people are going to be interacting in 10, 15 years. Like, it's just going to be the way that you build a new company or whatever happens. All the legacy stuff will continue because it does, right? It always does. But people still farm even after the Industrial Revolution. But everything new in 10, 15 years is just going to be a DAO. It's not going to be built the way that things are built now.
Awesome. Do you have any final words to leave us with?
I think that's it.
That was it. I think those were the final words.
Reach out if you're interested. And like I say, I'll be around at these and
All right. Well,
building.
again,
So
thank you, Dr. Neal Davis from the Urbit Foundation. And we will put this in our archives for everyone to watch whenever they want as well, because they are so thrilled to review all the exciting developments at Urbit. So thanks everyone for coming. We'll see you next month as well. For our next meeting, we'll be talking crypto tax policy. So that'll be always a fun event to have right before April. So at least for anybody who has to worry about US taxes.